Good morning all. In this video, we are discussing few topics from Chapter 3, Module 1. Topics covered from Chapter 3, that is modeling using entity and relationships, are relationship and relationship set, degree of relationship set, row and recursive relationship set, mapping constraints, participation constraints.
What is an relationship? A relationship is an association among several entities. I can also define the relationship is an connection between two or more entities with meaningful. Let us take an example of student and course entity. The student and course are the two entities with relationship as enrolled in. Same way, we can also have an entity, employee and department, where employee and department have a relationship as work at. If we consider an example for bank and customer, two entity, then relationship between bank and customer can be as an account. Relationship set. Relationship set is a set of relationship of same type. We call it as a relationship set. Let us take an example of student and course. Here, there are three students are in entity set, student entity set, and three course are in a course entity set. Now, let us see the relationship between student and the course. Now, student S1 has an entity set with course C2, and student S2 has an entity set with course C1, and student S3 has an entity set with course C3. What is relationship type? The relationship type represents an association between entity types. As we took a previous example, student and the course, the relationship type between student and the course is enrolled in. Same way, if you take an example, employee and the department as a two entity, the relationship between employee and the department as an entity type is work at, and bank and customer. If you take a two entity, customer and the bank, the relationship type between customer and bank can has an account.
Degree of relationship set. Degree of relationship set defines the number of different entities that participating in a relationship set is called as degree of relationship set. We can also define the degree of a relationship is the number of entity types that participate in the relationship. By seeing any ER diagram, we can simply tell the degree of relationship. That is, the number of an entity type that is connected to a relationship is the degree of that relationship. Let us take one example. If there are two entity types, customer and account, and they are linked using the primary key and foreign key, we can say that the degree of relationship is 2, because here two entities are taking part in the relationship. Based on the number of entity types that are connected, we can define the degree of relationship set. There are different types of degree of relationship set: unary relationship, binary relationship, ternary relationship, and n-ary relationship. Let us start with unary relationship. The unary relationship defines when there is only one entity set participating in a relation. Then such a relationship is called as an unary relationship. It is a case when an entity is related to itself. I can also define the unary relationship exist when both the participating entity type are the same. When such a relationship is present, we say that the degree of relationship is 1. Let us take an example. Suppose in a classroom, we have many students who belong to the particular club. The club are dance club, cricket club, basketball club, and so on. Some of them are club lead. So, a particular group of students is managed by their respective club lead. A group is informed or formed from the student, and also the club leads are chosen from the student. So, the student is the only entity participating here. We can represent this as unary relationship. And another example is, here person is an one entity and its relationship is married to. So, the person can marry to the another person. This is another example of unary relationship. And what the binary relationship says? The binary relationship says when there are two entities that participating in a relation, then such a relationship is called as a binary relationship. For example, student is enrolled in a course. Here student and course are the two different entities and enrolled is a relationship type. It is when there are two entities with different entities are related to one another, like a student is related to another entity called course as enrolled type of relationship. Relationship exists when exactly two entity types participates. When such a relationship is present, we say that the degree is 2. This is the most common degree of relationship. It is easy to deal with such a relationship as these can be easily converted into relational table. For example, we have two entity types, customer and account, where each customer has an account which stores the account details of the customer. Since we have two entity types participating, we call it a binary relationship. Also, one customer can have many accounts, but each account should belong to only one customer. We can say that it is an one-to-many binary relationship. What is an ternary relationship set? Ternary relationship set is a relationship set where three entities set participate in a relationship set. We call it as a ternary relationship set. Or the ternary relationship exists when exactly three entity type participate. When such a relationship is present, we say that the degree is 3. As a number of entities increase in the relationship, it became complex to convert them into the relational table. Let us look the example. We have three entity types, employee, department and location. The relationship between these entities are defined as an employee work in department and employee work at particular location. So, we can say we have three entities participating in a relationship, so it is a ternary relationship. The degree of this relation is 3. Next, what is an n-ary relationship? The n-ary relationship defines when there are n entities that participating in a relation. The relationship is called as an n-ary relationship. An n-ary relationship is when there is a complex relationship among various entities. These are generally avoided by programmers to keep database simple. N-ary relationship exists when n number of entities are participating. So, any number of entities can participate in a relationship. There is no limitation to the maximum number of entities that can participate, but the relation with high degree are not common because the conversion of high degree relation into relation table gets complex. We can represent n-ary relationship by taking an example of any library management project or college project. Example. Next topic is role and recursive relationship set. Now, what is a role? The function of any entity which it plays in a relationship set is called the entity role. Now, what is the recursive relationship set? When the same entity set participate in same relationship set more than once with different role each time, we call it as a recursive relationship set. I can also define the recursive relationship is nothing but simply an entity is having a relationship with itself. We also call it as a recursive relationship set. For example, let us take an example of student entity. Here, the student can be a class monitor and handles the other student. But a person who is working as a class leader is itself a student of the class. Hence, the class monitor has a recursive relationship of the entity student. Next topic is cardinality ratio. It is also called as mapping constraints. What it says? Number of entities in one entity set which can be associated with the number of entities of other set via a relationship set is called as mapping constraint or cardinality ratio. The mapping cardinalities are most useful in describing binary relationship set. We can also define the number of relationship instances in which the entity can participate is defined as cardinality ratio. The possible cardinality ratio are as 1 to 1, 1 to many, many to 1 and many to many. 1 to 1 cardinality ratio defines when each entity in each entity set can take part only once in the relationship. We call it as a 1 to 1 cardinality ratio. It means the single instance of an entity is associated with a single instance of another entity, then it is called as 1 to 1 cardinality. Here, each entity of the entity set participate only once in the relationship. Let us take an example. There are two entities, person and passport. In this entity, the person has only one passport and passport is given to only one person. And similarly, we can take another example. Assume that the only male can be married to only one female and one female can be married to only one male. This can be viewed as 1 to 1 cardinality ratio. Next type of cardinality ratio is 1 to many relationship. What 1 to many relationship defines when a single instance of an entity is associated with more than one instance of another entity, then it is called as 1 to many relationship. It means here an entities in one entity set can participate in any number of times in relationship set and entities in another entity set can participate only once in relationship set. Let us take an example. Customer and order are two different entities. Here, one customer can place 10 times of the order, but order cannot be placed by many customers. This is an example for 1 to many relationship. Similarly, we can also take an example of if there are two entity types, customer and account, then each customer can have more than one account, but each account is handled by only one customer. This is an example. We can say it as 1 to many relationship because the customer is associated with many accounts. Next type of cardinality ratio is many to one cardinality ratio. The many to one defines when entities in one entity set can take part only once in the relationship set, and entities in another entity set can take part more than once in the relationship set. We call it as an many to one cardinality ratio. Let us look at the ER diagram, which consists of two entities, student and college. In this ER, by seeing the ER diagram, we can tell that many students can study in single college, but student cannot study in many colleges at the same time. If we take another example of two different entities such as student and course are two entities. In this entity, the student takes only one course, but single course can be taken by any number of students. So, many to one relationship is observed in this example. It means that one course can be taken by any number of students, but only one course can be allotted to one student. Next type of cardinality ratio is many to many. Many to many cardinality ratio defines when entities in all entity set can take part more than once in the relationship. We call it as many to many cardinality ratio. Means here more than one instance of an entity is associated with more than one instance of another entity. Then it is also called as many to many relationship. Or entities in all entity set can participate any number of time in the relationship. Cardinality ratio is many to many. Let us take an example of many to many cardinality ratio. Here there are two entities, student and project. By seeing this ER diagram, we can say that the student can be assigned to many project and a project can be assigned to many students. This is what we call example for many to many. Similarly, we can also take an example as student and course. Here, student can take more than one course and single course can be taken by any number of students. This relationship will be called as many to many relationship. Next topic is participation constraint. What is participation constraint? The participation constraint is applied on the entity participating in the relationship set called as participation constraint. Means the participation constraint defines the least number of relationship instances in which an entity must compulsory participate. There are two types of participation constraint: total participation, partial participation. Let us take total participation. Total participation defines of an entity set represent that each entity in entity set must have at least one relationship in a relationship set. Each entity set must participate in the relationship. We call it as a total participation. Means it specifies that each entity in the entity set must compulsorily participate in the at least one relationship instance in the relationship set. That is why it is called as mandatory participation. The total participation is represented using double line between the entity set and relationship set. Let us take an example: student and the course. Here, each student must be enrolled in at least one course. That is mandatory. The double line between the entity set, student and relationship set enrolled in significance total participation. What is partial participation. The partial participation specifies that each entity in the entity set may or may not participate in the relationship instance in that relationship set. We call it as partial participation. That is why it is also called as optional participation. Partial participation is represented using a single line between the entity set and relationship set. Here, single line between the entity set course and relationship set enrolled in significant partial participation. Let us take example of two entities, student and course. Here, student and course. Each student must have at least one associated course, but course may or may not associate the student. By seeing this relationship set, we can say the student 1, 2, 3 and 4, all the 4 students must participate with any one of the course. But there are some courses may not be enrolled by any student. Here, student we can say it as a total participation, but course we can say it as a partial participation. This is an example for partial participation.